So 3.1 quadratic functions and models. And the big thing we're going to be doing is graphing quadratic equations, so graphing parabolas. But the first problems, they give us an equation and they want us to match it with like the answers, but we're just going to like talk about it and I'll just tell you which answer option that it goes with. So number 8, y equals, in parentheses, x plus 2 squared, and then plus 4. So they want us to find the vertex and tell which direction that it opens. So the general form would be y equals x minus h squared plus k, and the vertex is at hk. So opposite sign of what's in here, same sign of what's out here. So this one is a plus 2, so I need the opposite sign, so the x value would be negative 2. And then k is the same sign, so plus 4, so this is a positive 4. So this is the vertex. Do you have a note?
I gave it to Mr. Webster.
Okay. Well, if you gave it to Mr. Webster, then why are you like 10 minutes late to this class?
I had to use the restroom and I got here like maybe 5 minutes ago.
Okay. So this one opens up because it is positive. So if there's a negative sign out front, it would open down. But this one's positive, so it opens up. So the answer option, if you want to know, is letter A. Number 10, y equals negative, parentheses, x plus 2 squared plus 4. So, what would my vertex be of this one? Yep, negative 2, 4. And what way does this one open? Yep, opens down. So even when we get to the ones that we're actually physically graphing them, I like to go ahead and note like pretty much from the beginning, even if it's just a mental note, am I going to be opening up or down? Because that can kind of be your like clue, like did I graph this right when it's all said and done? Because there's a lot of times it's like it's negative and the person recognized that it opened down, but then their graph like opens up. So anyways, jumping to the actual graphing problems now, because that's the big stuff that we need to do in this section. Number 26, f of x equals x minus 5 squared minus 4. So we need to find the vertex, axis of symmetry, domain, and range. So we'll do domain and range after we graph it, but it wants us to find the vertex, which for this one would be what? Yep, 5, negative 4. So it's this opposite sign here, same sign here. The axis of symmetry is a line, and I abbreviate it AOS. It will always be whatever the x value of your vertex is, and we write it as x equals because it's a line, so x equals 5. And that's just a dotted line that we put on the graph to show like what it like revolves around so that it's the same on one side as it is on the other. And then we'll do domain and range after we graph it because it's easier to see once we graph them. So, come back. Setting up a little graph over here. Which way is this one going to open? Yep, so this one is up. So, I'm going to put some points on my graph here. All right, so axis of symmetry is at x equals 5, so I guess I need to go over here a little bit. So 1, 2, 3, 4, 5. So I put a dotted line here, and it rotates like it's symmetric about that, hence the axis of symmetry. I know the vertex is at 5, -4, so that's going to be down here. Now, I need to pick another point to see what happens on either side. When we get this far away, and especially in this particular form, I usually pick a point that's just 1 away from it. So since this is 5, I would do 6 here. So if I plugged in 6 to this equation, so if I did f of 6, I would have 6 minus 5 squared minus 4. And what would I get if I did that? -3. So that means at 6, I have a point at -3. The axis of symmetry tells me if I have a point here on the right side, like 1 away on the right, I also have 1 away on the left. And it's a U shape going up. So notice opens up, it's a U facing upward. All right, now domain. What is the domain for every single quadratic equation on your last test? Yep, -infinity to infinity, or we can just write it as all real numbers. Either way is fine. That will always be the case for every quadratic equation. So you can just memorize domain is always this, okay? Range is the y values that it takes on, okay? So in general, of the parent function, it is from 0 to infinity. But this one has been shifted down to -4. So it takes on all y values from -4 all the way up. So we write this including -4 to infinity like that. And that's how we do that. Any questions on that one? All right, 28. F of x equals -3 times x minus 2 squared plus 1. Okay, I was just making sure nothing was different when we had the thing out front, because I don't usually graph them like that. I was trying to refresh on that. All right, so what would the vertex be of this one?
2, 1.
Yep, 2, 1. And so my axis of symmetry is what?
2, 1. X equals, wait.
X equals 2. Just trying to get you in the habit of saying the x equals part, because it is a line and it's not completely correct if you just say 2. All right, and then we'll do domain, which we can already do as what?
All right, numbers.
All real numbers, or if you, like I said, if you wanted to write -infinity to infinity, that's fine. Range will have to wait until we get it graphed to see it. I mean, you could do it now, but it's easier to see. And which way is this one open?
Down.
Yep. So this one's going to be flipped upside down. All right, so I have axis of symmetry at x equals 2. Put my dotted line here. Label it. I have a vertex at 2, 1. Oh, not that. So then I would choose a number pretty much either side here. So let's just say, let's do 1 on this one. So I would have f of 1 is -3 times 1 minus 2 squared plus 1. So what would I get if I did that?
-1.
Are you talking about inside here for the final answer? So this would be -3 times 1 plus 1, which would be -2. So at 1, it's at -2. So that means 1 away on this side, it's also at -2. And then I can just connect it like that. All right, so based on that, what y values does this take on? Yes, but you need to flip it. It's got to be in numerical order. So -infinity to 1. Because it starts down here. You can't ever have a positive to a -infinity. It has to be flipped. Negative y has to come first. So this would be -infinity to 1, and we include 1. So if it opens down, the first thing you're going to write is always -infinity. If it opens up, the last thing you write is always going to be positive infinity. So that can kind of be your other thing to kind of help you. All right, so those ones are in vertex form. Those ones are a little easier to get the information you need for the graph. Not that the other ones are hard, it's just different. So let's look at one that's in standard form. So that'll be the ax squared plus bx plus c form. So 32, f of x equals 2x squared minus 4x plus 5. So this is A, this is B, and this is C. And any signs that they have to go with them. So like B is actually -4. So H, which is the x coordinate of our vertex, is equal to minus B over 2A. That should be a formula that you have in your notes. So plugging in negative, B is negative, so negative times -4, so ultimately that's going to be positive, over 2 times A is 2. So that's positive 4 over 4, which is just 1. Then to find the y value of the vertex, I plug this number here in for x. So f of 1 is k, which would be 2 times 1 squared minus 4 times 1 plus 5. And what do I get when I do that? 3. So now the vertex is 1, 3. So what is the axis of symmetry? Yep, x equals 1. Domain, all real numbers. And range we'll do after we graph it. Which way does this one open up? Yes, up. I don't know why I said which way does this open up, like I was, it's fine. Trick question. Okay. All right, so axis of symmetry at x equals 1. Vertex at 1, 3. So anytime I have one that's written in standard form, if the axis of symmetry is close to 0, I like to plug in 0. Any guesses as to why?
Because it's the easiest.
It's the easiest because everything's going to cancel except for whatever C is. Because when I plug in 0 for X, A goes away, B goes away, all I'm left with is C. So when X is 0, Y is 5. And 1 away here, go 1 away on this side, and there's my graph. So what would the range be for this one?
3 to infinity.
Yep, 3 to infinity. Alright, I don't normally do this, but the other even one has excessively large numbers, so I'm going to do an odd one. So we can do one more in standard form. F of x equals negative 2x squared minus 12x minus 16. So I need to find my vertex. To do that, I need to use the minus b over 2a to find the x coordinate. So h equals minus b over 2a. B is negative 12, so that's going to end up being a positive 12 on top over 2 times negative 2. 12 divided by negative 4 is negative 3. And then for k, I plug in that value, so I get negative 2 times negative 3 squared minus 12 times negative 3 minus 16. So this is 9 times negative 2, so negative 18 plus 36 minus 16. Is that 2? I think. So my vertex is at negative 3, 2. So my axis of symmetry is that x equals negative 3. What's the domain? All real numbers, and we'll find range in a second. Which way is this one open?
Down.
Yep. Alright, so my axis of symmetry is at x equals negative 3. Get that on there. Vertex is at negative 3, 2. So now, if I plug in 0, which I still can, but that's 3 away from my axis of symmetry, I would be all the way down at negative 16. That's fine if you want an excessively large graph. I don't, so I'm going to choose a different number. I'm going to choose negative 2. So I'm just going to do it up here so I can see the equation. So negative 2 times negative 2 squared minus 12 times negative 2 minus 16. So this is going to be 4 times negative 2, negative 8 plus 24 minus 16. Oh, well, that actually works out nicely. That ends up being 0. So at negative 2, it is 0. 1 away on that side, 1 away on this side, and we graph it going down. So what's the range of this one?
Negative infinity 2.
Yep, negative infinity to 2. All right, any questions on any of that? All right, your problems then are 7, 9, and then graphing ones, let's see, 25, 27, 29, and 31. And if we didn't have one like this, but if there was not a number in front of x, like if it was just x squared, then make sure you plug in 1 for a. So there's like an imaginary 1 sitting there. So just as a reminder, because one of them is like that. We didn't do one like that.